Alright, in this second tutorial of the series, we're going to be talking about jit.gl.gridshape and jit.gl.mesh, which are really just ways of creating 3D geometry using OpenGL in Max MSP. So in order to do that, the first thing I'm going to go ahead and do is create my jit.world. I just started with an empty patch, so it should be easy to follow along. So I'm going to say jit.world. I'm going to give it a name, RTM, just as last time. And I'm just going to specify from the get-go at floating 1, just to have the window by my side at all times. Great. And let's also add our send draw. As you remember, the second outlet of the jit.world is sending a bang at every frame because jit.world is kind of doing its own timing internally. And I'm going to add one more option to the jit.world, and we're going to see why in a second. Auto handle 1. All right, looks like this refreshed our window. I'm going to talk about it in a second. But yeah, for now we just have an empty world, nothing's going on in there. Oh, let's not forget to add a toggle to turn it on. I always forget to do this. Let's turn it on. We should see our screen turning slightly gray, which is our sign that the world is working. All right, so let's get started with the grid shape object that I was talking about. It's called jit.gl.gridshape. We need to pass it the name of the world as usual, so RCM. And for now, I'm going to leave it like this. And we already see that our world got populated with a shape. It kind of looks like a circle. If we bring our mouse into the world window and drag it, we are able to rotate the object. That's what the auto handle option of the jit.world is doing. It's allowing us to control the world inside of here using our cursor. If we hit control and then move our mouse with the left click pressed, we can move the world. And if we hit Alt and move our mouse with the left click pressed, we're able to zoom in and out. So it looks like jit.gl.gridshape added a sphere into our world. And let's see what other options for shapes we have. In order to do that, I'm going to use the Attrui object, ATTRUI, and connect it to jit.gl.gridshape. This is kind of like a hacky way of looking inside all of the possible options of one object. I know Matt doesn't particularly like it, and it's not particularly recommended for production patches, but just for kind of exploring options inside of objects, I find it to be quite useful. And let's see, we're going to work with the shape property at first. And let's make this a little bit wider so we can see. I'm also going to zoom in because it's kind of tiny here. So the shape is a sphere right now, and it looks like we have a bunch of presets that we can work with, right? Like there's the sphere, there's the torus, cylinder, cube, etc. Right? Pretty much like 3D geometrical primitives that Max is giving us kind of for free without us having to build meshes from scratch. All right, let's see what we can do with this shape. It looks kind of boring right now, it's just gray. So why don't we try adding a video mapped on top of the shape. I'm going to change this back to a sphere. I think it's a little bit more pleasant than the capsule. And in order to map a video onto this 3D geometry, conceptually we want to load in a video like we've done before, just with jit.movie. Convert that video into a GPU texture, like we were talking about in previous tutorials, send it from the CPU onto the GPU, and then map that texture onto this geometry. Unfortunately, Max makes it really easy to do that mapping. So let's start by saying jit.movie and have the read message, which allows us to select the movie from our hard drive. Let's do the receive draw and connect it to our jit.movie. We might not even need that, but we will figure that out in a second. And let's see, let's do a jit.p window just to make sure that our movie has loaded. And all right, let's do a read. That's not what I want. I want my desktop here, and I'm just going to choose a random screen recording um, from some of my personal collection. All right, so we see, oops. We see the movie here rendering in this P window. It's just a screen recording of a Voronoi algorithm running, um, nothing special. But we have a movie that's loaded. That's great. I'm going to remove the P window for now. And as I was mentioning, we want to turn this into a texture. So let's first add the output texture parameter, output texture 1. And then we're going to use a new jit.gl object, which is called jit.gl.texture. And we're going to give it a name. And you're going to see in a second why we need to do this. So let's just call it text movie. And let's send the output of our movie into this jit.gl.texture. So nothing crazy so far. We've read the movie from the hard drive. We've converted it into a texture, and the texture has a name that's called text movie. So right now, if inside of our jit.gl.gridshape, we use the texture, the texture attribute, and give it the name of the texture that we've just created, which is text movie, we should start seeing the movie play onto our sphere. However, that does not seem to be happening. Let's figure out why that is. All right, feel sorry about that. It turns out that whenever we add a texture, texture and give it a name, so text movie, which was the name in our case, sometimes it works from the first try. If that doesn't, you'd need to hit read again on the jit.movie and reload the file that you're using. Earlier, when I tried, the screen turned black, so that was the issue. Let's zoom out a little bit. So right now, as you can see, we just have a simple video file mapped onto a sphere. If we change the shape, we see it's mapped on different shapes. Right. All right, very cool. Let's do one more thing. Let's change the shape of this into a, let's say, cone, and let's add another true object. First of all, I want to be able to control the position in the world, because navigating with the mouse can be buggy sometimes, and being able to adjust the position from here is a saver. And I'm going to add one more tree object, and we're going to look at yet another property of jit.gl.gridshape. And this time we're going to look at dim, the dimension. All right, so in my understanding, this dimension is kind of the resolution of the 3D shape that is being presented on the screen. It might be the number of points that are used to generate this shape, or it might be something slightly different, but it's kind of around that. So, for example, if we change the first parameter, if we decrease it, you can kind of see that the bottom of the polygon, which is normally supposed to be a circle, becomes like a polygon with 9 sides. If we go even lower, like if we go to 5, it becomes a square. And the higher this dimension is, the more it's going to look like a circle, because it's going to be a polygon with like 217 kind of equal sides building towards that. We can make the same kind of change for the second dimension. We're not going to see any obvious changes in here. I think the sphere might be a better candidate for that. As you can see, it becomes just like a more basic shape made out of less points, even though it's supposed to be a sphere. All right, very cool. So now that we've covered the dimensions of the grid shape, let's do something even more interesting with it. Let's try to slightly change the geometry of this sphere, or like the geometry that Max is giving us, based on some other input, based on some sound input, for example. And in order to do that, let me just get my notes. We're going to use a new object that is called jit.gl.mesh. All right, so in the 3D world, a mesh is a collection of vertices, edges, and faces that kind of define the geometry of a three-dimensional object. And JIT allows us to define meshes using matrices, basically. They have like a kind of a particular format for how a mesh should be described using a matrix with many planes. However, the good news is that our jit.gl.gridshape has a matrix outlet, which we can enable. So we can kind of turn the grid shape object into something that just gives us a mesh of the geometry that we select, right? A sphere or a cone or a cube, and outputs the format, or like outputs simply the mesh of that in jit.gl's matrix format. We plug that into gl.mesh. We alter it using some other operations that we're going to do in a second, and then delegate the texture application onto the object to jit.gl.mesh. All right, so in order to do that, let's first append, or let's first make jit.gl.gridshape use the matrix output, and we can do that using at matrix output 1. And we see that it's not sending a texture to our world anymore, because right now all of its output is coming from here. And for the time being, we can just plug it into jit.gl.mesh. We should make sure to give the mesh the name of our world, and we should make sure to also give it the texture attribute of our texture. So in this case, grid shape doesn't need to know about the texture anymore, right? All we want grid shape to do is to send us the representation of the mesh. All right, so far so good. We haven't really done anything besides adding this mesh into the mix. So let's take a super quick look at this matrix that is being outputted from the jit.gl.gridshape object. In order to do that, we can use the jit.matrix info object. I always kind of forget what kind of like how to use this object, so I always just end up opening the help patch for it and copy pasting. Let me unlock it first. And copy pasting how the Max help people use it. Right, and this object basically tells us how many planes a matrix has, what data type there is in that matrix, and how large, like what are the 2 dimensions of each one of the planes. So like in this example that we just copied, there's a 4-plane matrix with car numbers inside of it, which means that they're from like 0 to 255, and each one of them is 320 pixels wide by 240 tall. And this is probably just a regular image, the 4 channels being red, green, blue, and alpha. But let's plug our jit.gl.gridshape in here, and we see that we have a matrix with 12 planes, each one of them being a float number. and each one of them is 20, has a width of 20 and a height of 20. Um, we realize that this 20 by 20 corresponds to the dimension that we specify for our mesh, right? So like the moment we increase the dimension here, kind of the resolution of our object, uh, the dimensions of each one of the 12 matrices inside of the larger matrix increase as well. And I don't really know what each one of those 12 planes is. I think you can find that out by going into the Max MSP documentation. But I think what's important for the exercise that we're doing is to remember that the first three have to do with the position. Like I think um, each one of these 49 times 49 points has an X, Y, and Z coordinate in space. And I think those three are stored somewhere in the first three planes. And then some other planes talk about the normals at each one of the points. They talk about lightning, they have lightning information and a few other things that are kind of like necessary pieces of information in order to be able to turn simply a collection of points in three dimensions into a mesh that gets rendered as like a continuous object. All right, so now knowing that this is a matrix, kind of like any other matrix that we've seen also when working with video, we could try maybe altering the XYZ coordinates of each point by doing a matrix operation, by adding them with a value that's coming from a different matrix. And in order to do that, we're going to use a piece of audio. Let's see here. I'll use the jongly one. And these are just like max default sounds that you can use. I'm going to create an easy DAC object in order to make sure the sound is on. And I'm also going to create a live.gain object just in order to have control over the volume. I'm going to send the two channels from the sound player into the gain object and then send its output into our easy DAC. So now when I play it, you should be hearing it through my speakers. All right. So we have a sound, and there is this really fun object that's called jit.catch. And jit.catch is a way of turning audio signal into a matrix. I don't know exactly what it does in the background, but it's kind of taking data from the audio and turning it into a matrix or into something that is visual. And let's see, we can connect the jit.catch to a P window just to see what's coming out of it. Sorry if you heard some noises earlier, that was my cat scratching my chair. I apologize about that. Jit.catch needs to take a Q metro, but we can actually just do a receive draw and give it, receive draw and give it signal from there. Great, and then we also need to give it a parameter which is called frame size, and I think this has to do with like how many samples of an audio it should take into consideration when generating one matrix. I'll just give it 400, and then we need to send the audio output into the jit.catch input, not into the receive draw input. Great. Maybe I forgot something, but let's try this out. Yeah, this is working. As you were able to see, whenever the sound was playing, we were able to see a kind of a visualization of what was going on inside of the music. So let's use this visualization in order to kind of distort the mesh of our shape and make it sort of responsive to sound. I'm going to move this matrix info a little bit out of the way since we're not really using it. And in order to do that, we're going to use the jit.op object. This is a jit object that allows us to do operations with matrices. And we're just going to do a simple addition. So the way it works, you just specify which operation you want to use using the @op parameter, and then tell it plus. Because we want to add. And in this case, the left inlet is going to be our jit.gl.gridshape output, and our right inlet is going to be the matrix that's coming out of jit.catch. I should mention that these matrices have different dimensions, different sizes. They're not matching in any way, shape, or form. But the addition is going to happen somehow by Max's logic, and we'll see what comes out of that. The result of the operation is coming through the left inlet. I'm going to connect that to the jit.gl.mesh, and let's see, let's start playing the sound and see what happens. All right. Oops. Right, so our mesh was getting deformed based on the matrix that you saw in the right side, the one that's generated from audio. I'm going to play it one more time. All right, and yeah, I'm going to actually change this a little bit so we can keep playing on a loop quietly because it's kind of loud. Okay, so I'm going to reduce the volume. I'm going to start playing it and make it loop. All right, so you see the geometry of our mesh distorting based on the matrix. If we increase the dimension, we might be able to see a slightly different kind of distortion. Oh, now my computer is getting slow, right? Just because the sphere is built out of so many more points. And if I'm going to turn it back down to a few tens. If we wanted to, for example, make it a little bit more subtle, right? Like right now you see it's a very intense kind of distortion. We could adjust the matrix that's coming out of jit.catch. We could say multiply that with 0.2 or 0.1 in order to make the change a little bit more subtle. And we could do that again with jit.op using the multiplication operation. I'm going to place it in here in between these two. And the multiplication, you can also multiply or like use the operations with a scalar. So in our case, we can just multiply it by 0.6, right? So now you see it's a little bit more subtle. And again, we can change the shape and we can see it being applied on different geometries.